Question 69 to 71. The formation of bromoethane from ethene. Okay, so they show you the reaction, give you the Gibbs free energy, and give you the equation for Gibbs free energy. And hopefully you've seen these equations before, you've used them before, so you're comfortable with them. Question 69. If more hydrogen bromide is added to the reaction mixture after equilibrium has been established, the value of equilibrium constant will be. Well, if you look at the given reaction, if more hydrogen bromide, hydrogen bromide is added, then, it would shift to the right, of course. It would shift the reaction to right. But, really, they should have done a two-way arrow of equilibrium for the reaction. But it's okay. It would shift the reaction to the right, but it doesn't change the equilibrium constant. The equilibrium constant tells us what the concentrations of the different compounds will be at equilibrium. The KEQ, is the product of the products over the products of the reactants, and they're raised to the power of the stoichiometric coefficients. And this ratio, it can change with temperature. If you raise the temperature, it can change, but it's not going to change because you put some different concentrations in, because the other concentrations will balance. And so at equilibrium, you will have, you will get back to the equilibrium constant. And in fact, when you're out of equilibrium, that's a different constant. It's called the reaction quotient, and they won't ask you that question, but they won't ask you, what is the reaction quotient? It's not their style, but they could present it to you. And the KEQ is a specific condition in which your reaction is in equilibrium, and that is a constant at a given temperature. And in fact, even if you add a catalyst to the reaction happens faster. The KEQ is unchanged because the KEQ will be the same at equilibrium. So the answer for 69 is B. It's equal to its original value. 70. The rate of reaction forming bromoethane doubles if the initial concentration of ethene is doubled. Okay, so you have the rate law, and you have K, and you have ethene here, and you have HBr here. So we're told that the rate of the reaction doubles. The rate of the reaction doubles if the initial concentration of ethene doubles, while the concentration of this stays the same. So if this doubles when this doubles, then I know the exponent here is 1. Okay, so you don't have to write 1, but in your mind it's a 1-to-1 relationship, because if it triples, it triples, it quadruples, it quadruples. So it's a 1-to-1 relationship here. And then they tell us that the initial concentration of hydrogen bromide, and it quadruples, the rate quadruples if the initial concentration of hydrogen bromide is doubled. So if by doubling this goes 4 times, that means this must have the exponent 2. So we can describe this reaction as first order with respect to ethene, second order with respect to hydrogen bromide, or we can say this reaction is a third order reaction, which is the sum of the exponents. 71. Which one of the following is a correct statement about the reaction forming bromoethane? Okay, so first of all, we know that the central equation is delta G is equal to delta H minus T delta S. And we see the values that they give us. We're told that the reaction at 298 are minus 48 for delta G, minus 45, kilojoules, and minus 85 over here. And this is a reaction at 298 Kelvin. So this is happening at 298 Kelvin. Okay, so looking at the equation, we have 298 here, but we'll take this as 300. And we'll add 85 to both sides of the equation. And so we will have 40 here, and that's equal to minus 300 delta S. And so we get that delta S is equal to 40 over 300. We have these zeros that cancel, and we have minus 4 over 30. Okay, so we cannot be surprised that the entropy is negative, because if entropy is increasing, then entropy is positive. If entropy is decreasing, meaning we're getting more organized, less random, then it's negative. Because if you look at the reaction is going from 2 molecules down to 1 molecule. And so there's an increase in organization or structure that way. So entropy is negative. But look at entropy. Isn't that a really small number? That's a very small number when we're talking about these big numbers, 85, 45, 300, and entropy is this really tiny number. Anyway, we'll keep that in mind. So now let's look at the answer choices for question 71. The reaction only occurs at temperatures higher than 298. Well, we know that the reaction will occur as long as Gibbs free energy is negative, right? So if Gibbs free energy is negative, it means it's a spontaneous reaction. Well, here is the entropy. If we start bringing down this temperature, we lower the temperature from 300 down to even 30, the effect, because of the entropy, is so small, 30 times this, the 30s will cancel, you're only left with a minus 4, and so it doesn't affect delta H at all. So even reducing the temperature by 10 times still does not affect delta H, because delta H is dominating this equation whether or not you change it a lot. So A is definitely wrong, because we can reduce the temperature and the reaction is still going to be spontaneous, still be negative. B, the entropy change for the reaction is positive. Nope, we just saw it, we just calculated it's negative because there is less disorder in the product. Now, we're going from 2 moles to 1 mole, there's more order. C, the reaction does not occur spontaneously because the change in Gibbs free energy is negative. They're trying to catch people who just don't know what's happening. So a negative sign for Gibbs free energy means that it's a spontaneous reaction. And D, the reaction occurs spontaneously as the enthalpy change dominates the effect of the entropy change. Because here's the entropy change, very, very small, doesn't have that effect of altering this big negative delta H, and so the reaction is spontaneous. I just want to put a little asterisk at the bottom. I'm sure I'm hoping you're familiar with this already, but the spontaneity of the reaction does not necessarily mean that delta H is positive or negative. I know some people feel that, if delta H is negative, it must be spontaneous because energy is given off, it's more stable products, all of that, but it's not true. The spontaneity of the reaction is dependent on Gibbs free energy and whether or not it is positive or negative. Delta H can have a very important effect, but it's Gibbs free energy that determines the spontaneity of a reaction. And if you want to do some more reading up about Gibbs free energy and spontaneity, you can go here. And also these sections are for rate law, which was also covered in this section.